Hello, students. All right, we are beginning our notes today in our next topic. And there aren't many notes to this topic. We have many other things to do with this topic. But regarding the notes, let's get started right now with our topic called electromagnetism. So, electromagnetism, when we are finished with the lesson notes here today and tomorrow, we are going to be watching some videos and performing some activities dealing with electromagnetism. So, let's get into it here. What is electromagnetism? Very simply put, it's the combination of two words. And so electromagnetism can broadly be described as the relationship between, you guessed it, electricity and magnetism. And the discoveries made in the 19th century regarding electromagnetism changed the entire future of planet Earth. We have learned so much about electromagnetism over the last 150 years. It is amazing, really, truly amazing what we have discovered. Hans Ørsted in 1820 is credited with being the individual who discovered electromagnetism itself. In the early part of the 1800s, there were many people who were gaining an interest in experimenting with electricity. And you may have learned about the famous Ben Franklin experiment with the kite in the air in a thunderstorm, studying static electricity of storms. Well, there were others doing experiments too. Unfortunately, and by the way, don't ever try that experiment. Many people tried to replicate that experiment and were electrocuted to death. So don't play around with kites during an electrical storm, please. But Hans Ørsted discovered this relationship between electricity and magnetism by making some simple observations here. He passed an electric current through a wire and discovered that it produced a magnetic field. This simple observation, this simple experiment has really defined the modern technological future that we experience today. Think in your life how many devices you use that are based on electricity. Before Ørsted's day, in fact, before the Civil War, in the middle part of the 1800s. In fact, let's move it up even more. Before the late 19th century, nobody had any devices that used electricity because electricity wasn't used. No one understood what electricity even was, other than seeing a lightning bolt catch a tree on fire. Who would want to use that in your own home, right? So electricity itself has really only been around a relatively short period of time in human history. And so the work of Hans Ørsted and others, as we will explore this week, were really landmark discoveries that were made that shaped the modern world. I mean, you can't even be watching this video without electricity, whether battery power or through an outlet, doesn't matter. The device that you're watching me on right now is using electricity. It is an incredible, powerful force. Now, electricity and magnetism can be used in a variety of ways, and one of the ways that we have discovered over time is what is called an electromagnet. Now, early scientists played around with these relationships between electricity and magnetism, and we're going to watch some videos on that very idea in just a little while. But as we are learning about electromagnets, let me just tell you quickly what it is. An electromagnet is a solenoid, whatever that is. I'll tell you in the next slide, with a magnetic material inside. Now, you'll notice here in these diagrams, this looks like a coiled wire with a magnet in the middle, which it is. This diagram here looks like a metal nail of some kind with a coil wire around it, which it is. So an electromagnet is a solenoid with a magnetic material inside of it. So what is a solenoid? You may have guessed already. The solenoid is a long coil of wire with many loops. So take a wire and coil it up and you've got a solenoid. And it acts like a magnet when electricity passes through it. So when you pass electricity, the flow of electrons through a coiled wire with many loops in it, that coiled metal wire becomes a magnet with a north pole and a south pole. And under the right circumstances, the north side of that solenoid will always point north. And boy, the ramifications, the potential uses of solenoids is incredible. From starting your car to enabling spacecraft to navigate through space. Solenoids are incredibly useful devices on a small scale as well as a large scale. Now, I'm going to mention one more application of electromagnetism here before we end for the day, because we have lots of other videos to watch here that I would like you to explore. So the last thing, maybe I'll show you two more things here. I'm going to show you two more things here. First is an electric motor. In recent years, and I say recent years because I've been around a few more decades than you, but certainly in your lifetimes, this is like commonplace, electric motors, especially in cars. An electric motor is a device that converts or changes electrical energy into mechanical energy. Now, in the last topic, we learned how, and in future topics too, for that matter, we'll learn how mechanical energy, like from wind or water, can be converted into electrical energy for us to use. Well, an electric motor does the opposite. An electric motor takes that electrical energy and converts it into mechanical energy. So here's an example, a cutaway of an electric motor. And you can see its guts inside, but as electricity passes through an electric motor, creating a magnetic field, and there are magnets in an electric motor as well, those stationary and those movable magnets push one another around and cause an axle to spin. These are the kinds of motors that we have in remote control cars, or maybe you have an electric vehicle at home, or your parents might have an electric vehicle which uses an electric motor in an actual car. Pretty cool. All right, we'll finish up today's notes with this term called galvanometer. A galvanometer is an instrument used to detect small currents. Now, this is an old-fashioned galvanometer, although very effective. This utilizes analog technology, a needle that moves. In the lab, we're going to be using digital galvanometers, which are actually called multimeters. And the multimeters we use measure not just small currents of electricity, but a whole host of other things. And we'll be using multimeters for the remainder of the year in doing various experiments with energy, more specifically electrical energy. So we'll save the rest of our notes until tomorrow. Pay attention. Don't close your books yet because we've got some videos to watch that I think you'll find interesting. And so until next time, I'll say bye bye.